Hello everyone. Hope everyone are fine and safe. I guess you have your exams maybe on 18th, right? Yeah. So all the best for your exam one. Make sure you get a good grade because exam one is always easy. Okay. Let's get started with lab 4. Now, if you have questions on lab 3, because it is due tonight. So if you have questions on lab 3, stay on the Zoom. I can take a look at your questions after I complete lab 4. Okay, sounds good. Fine. So let's get started with lab 4. Now, as we have seen in the previous lab, we are just finding the area, right? One is by integrating. And next lab, we saw how to do the U substitution, even by hand, and also Matlab, by using Matlab. And in the previous lab, we saw how to find the area, volume, and how to integrate if you have a multiple functions, right? So we saw all those. Now we have another method, integration method, that is integration by parts. You would have learned this in your lecture section. Okay, so how does this work now? Now you have a formula for integration by parts, right? So you are going to apply the same formula and find the solutions for all the integrals. So in lab 4, you will have in total 7 problems. Okay, you have 7 questions. Some of them, most of them are quite easy. You might find difficult in problem 4 and in problem 6. Okay, and the rest are easy. So I am going to do those difficult problems and I will leave you the simple problems for yourself. Okay, so that you can prepare well for your exam 1. You can also complete your lab. Okay, fine. So remember this one, which is given here, only this one. Okay, only this question is the example problem. So you don't have to include this in your assignment. You don't have to solve. Okay, so your assignment questions will be starting from here. Question 1 to question 7 here. Okay, now today we will learn how to apply integration by parts for the following problems and how to solve this using Matlab. Okay, now what documents do you have to submit to the Blackboard as assignment? Now for that question, I don't think so you can do your hand calculations in this space. So if you are comfortable, you can use this document. If not, you have to do your hand calculations in a sheet of paper, scan it, upload it to the Blackboard, along with a Matlab PDF. Okay, so you will be doing Matlab coding and on how to solve this one in a Matlab, right? So you are going to export that to a PDF, okay, and then upload that PDF to the Blackboard along with your hand calculations. Got it? It's the same way like you did last time, but only difference is this time you are going to include the Matlab code as a PDF. No. So for the previous lab, no, there is no need to upload Matlab code for the previous lab. Yeah. Okay. I hope it is clear. Okay, let's get started. I don't want to do the first problem because it's quite easy, right? Okay, let us see. Let me do second problem. Okay, problem 2. Because see, this is integration by parts, right? So you know the formula. You will take first function u as x square, and then dv as ln of x dx along with dx. Okay, then you will find what is du by dx, that is 2x dx here, and then you will integrate what is v here, right? Integration of ln of x dx, you will find what is v, and then this is the formula, uv minus v into du, right? So you will be using this formula. This is called integration by parts. So you will be using this formula and solving the problem. Okay, you just have to plug in whatever you have computed here. Got it? Okay, so that's how you find the solution step by step. Okay, so that was about problem 1. Now, problem 2, question 2. You can see that there is a small table here, right? So you might be wondering how to solve this. Now you can solve this using the same formula here. Okay, you can do that. But the problem is you have e to the power of 2x. Remember, when you integrate e to the power of 2x, you get e to the power of 2x by 2. When you still go on integrating it, you will get by 4, by 8, right? It goes on. So when you are using this formula, you can use this formula, but the problem is you have to apply this formula 3 to 4 times. Okay, you have to apply this formula 3 to 4 times to find the solution here. Okay, so that's the reason we are going to use another integration method, that is tabular integration. Fine. So let's see how to solve this using tabular integration. So this method is very easy. It is too short, but only thing is you're not supposed to get confused. Got it? So I will explain you step by step on how to solve this. Okay. So first thing is, let us fill the table first. Got it? Now here d means you are going to find the derivative of the function, and I is you are going to integrate the function. Integrate. Like you take u equal to x cube and dv equal to e to the power of 2x dx, right? That's how you will take when you are using integration by parts. Sorry for the handwriting. U equal to x cube and dv equal to e to the power of 2x into dx. Okay, sounds good. Now you are going to do the same thing here. When in case of tabular integration, you are going to put the function where, the u function in the derivative column and the dv function in the integration column. Okay, clear? Okay, so what is the next thing? Now, as I said you, d stands for derivative. So you're going to find, or you're going to differentiate this function until the end. Let's see how to do that. Now x cube, what is the derivative of x cube? It is 3x square, right? Good. Okay, Joseph. Now you are going to derive this function, not this again. Okay, if you do that again, you are going to get the same answer. So you are going to derive this function. So this will be, right, 6x and 6 and derivative of a constant is 0, right? So you'll get 6 here, 0 here. Excellent. Now, what about the second column? The second column stands for integration, right? So you are going to integrate this function, e to the power of 2x dx. Okay. What is the integration of e to the power of 2x dx? Like I showed you just now, it is e to the power of 2x by 2. Got it? Do you want to know how I got e to the power of 2x by 2? Do you want me to explain that? Okay. So now this is just an extra step. You don't have to do this for in your assignment. You can straight away write the answer there. Now we can use u substitution here. I will take u as 2x. So my du will be equal to x dx. Oops, 2 times dx, right? Or oh, I need dx, right? So du by dx equal to 2. So dx will be equal to du by 2. Remember the u substitution we did in, I think in lab 2 or 3. Okay. Now you're going to apply the same thing here. Integration e to the power of u, and dx is du by 2, okay. So since 2 is a constant, I will just keep it outside as half integration of e power u du, right? Now half times, what is the integration of e to the power of u or e to the power of x? Anything? What is the integration of e power x dx? So you have a standard formula for this, okay? So integral of e to the power of x is e to the power of x plus c, because it is indefinite, right? So I'm going to use the same formula here. Instead of x, we have u, right? So I will take it as e to the power of u plus c. Okay, that's how I get e to the power of u by 2. Okay, now we know that e to the power of u is 2x, right? So e to the power of 2x divided by 2. Okay, now I will give you a task. Okay, I will give you one task now. So you know how to integrate e to the power of 2x. So I want you to fill the rest of the blanks here. Okay, take your time and let me know the answers. So you are going to integrate e to the power of 2x. So when I integrate e to the power of 2x, I get half times e to the power of 2x, right? The same thing I'm writing here. Now, what is the answer when you integrate half times e to the power of 2x? Right. It is 1 by 4 e to the power of 2x. So when you integrate this, you will get 1 by 8 e to the power of 2x. When you keep on integrating, you get 1 over 16 e to the power of 2x. Now see how the exponential function is acts as a recurring function, right? So when you apply integration by parts, you have to do this 3 or 4 times. The reason the function will stop at a point is because of the 0. If it was something like this, and let's say, let's take it as this. Okay, you can multiply here, but what if you have, let's keep a recurring function, sine of x e to the power of x. Okay, when you have this type of function, you can see that sine x, integration of sine x is cos x. Now, if you integrate cos x, you will get sine x. It keeps on going, right? So likewise, when it comes to exponential, it becomes a recurring function. So to solve this type of functions, you will have to use a different method. If you use integration by parts, you will get stuck. Okay, you can't even use a tabular integration in this kind of function because you never meet a constant. Okay. Now let us get back to the problem. Let's not go deep into that. Okay, here, this is the question. Okay, now that we have filled the table here, I'm going to erase the extra things here just to make some space. Okay. Now, so after you fill the table, you have one important thing to do is to put the sign next to the function. Okay, you have to denote what sign you have for each function. Now, when it comes to tabular integration, you have to use both positive and negative sign alternatively. Got it? So this, you will be starting with positive always, and then you will go to negative here, positive, negative, positive. Now you might ask me, what if you have a table like this, wherein you might have, for example, this is just an example. What if you have negative x cube here? So obviously this will always be negative, right? So what if you have negative here? Then also you are going to start with the positive, but you are going to retain the negative sign inside the table. Okay, understood? You might not have this type of problem in your lab, but you just have to be careful about this. Okay, now, yeah, let us get back to the problem. Now, integration of x cube e to the power of 2x into dx. Now, how can I apply this one as a solution to this problem? Now, what do we have to do next? Next is that you are going to cross multiply x cube with half, 3x square with 1 by 4, 6x with 1 over 8, 6 with 1 over 16. Now we are going to eliminate this completely. We don't want e to the power of 2x. And also 0. Why 0? Because if you multiply, say 1 over 32, because when you integrate this one, you get 1 over 32 e to the power of 2x. Even when you cross multiply this, you're going to get 0 there. Okay, so 0 is like a stopping criteria, I can see. I have stopped here, not because the table is ending, not because of that reason. The reason I stopped here exactly was because I got 0. Okay, that's where you're going to stop too. Got it? Okay. So for this problem, we are going to eliminate the last portion here and the first one. Got it? Okay, let's see how to write this as a solution. Equal to, now as I said you're going to cross multiply, right? So first is a sign. What sign we have here? Positive. And then we have x cubed. And I'm going to multiply this to the half e to the power of x, right? So x cubed multiplied, because cross multiplication, half e to the power of 2x. Okay, positive outside. And then what will be the next sign? Any guess? So I used positive because I have positive sign in front of x cubed, right? And then I multiply this with half. Okay, so what is the next step? Next step is I'm going to multiply 3x squared with 1 by 4. But what is the sign I should be putting here? What sign should I use? Is it positive or negative? Good. It's a negative. Why? Because you have negative sign before the 3x squared, right? So I'm going to use negative here, and then 3x squared multiplied with 1 over 4 e to the power of 2x. Okay, and so on. Plus 6x into 1 over 8 e to the power of 2x. Okay, and last one, negative 6 into 1 over 16 e to the power of 2x. I don't want 0 because if you multiply anything with 0 is 0. Right? Okay. Now the next thing is simplifying this function. Okay. I want you to do along with me. Let's see who will get the right answer. So I will simplify. I will just write one more step here, and then you have to tell me what is the right answer. Okay. Okay. So if I want to simplify, I just take x cubed inside. So that will be e to the power of 2x divided by 2 negative 3x squared e to the power of 2x divided by 4 plus. Now I can simplify this. 2 3s are 6, 2 4s are. So this becomes 3x e to the power of 2x divided by 4 negative 8. So 3 e to the power of 2x divided by 8. You can stop here, or else if you want to take e to the power of 2x outside, because you have common in everything, and then write rest of the things inside, that is also fine. Okay, you can simplify further. You can take LCM, group everything into one term. because when you do this in Matlab, that will give you the most simplified version. So if you want to stop here, that is fine too. But remember, when you do this in a Matlab code, you might not get the same answer. I mean, same form of answer. You might get a simplified form. Okay. Okay. So this was about problem 2. So this is how you calculate or write the solution using tabular integration. Okay, do you want me to wait for a while until you guys make a note of it? And if you did not understand any step here, it might be anything, it might be too simple. Please ask me, I can explain you that step. You have your exams maybe in 1 or 2 or 3 days. So make sure you are ready for that. So if you have any questions in this step, in any step, please let me know. Okay. Okay, let us proceed with problem 3. Okay, when it comes to problem 3, I'm going to erase this because this is for problem 2. So okay, so this was the end of problem 2 here. Okay, now for problem 3, you're going to do the same thing. You'll take x cube in the derivative, cos x in the integration, and you will do till you meet 0 here. Okay, you get 3x square here. I guess you will get the same answer because you have x cube here and you have x cube here. So the first column for problem 2 and problem 3 will be same. Only thing is you have to integrate cos x. So integration of cos x is sin x, integration of sin x is negative cos x, and so on. Okay. So you will be doing the same procedure. Remember, you have to use positive, negative, positive, negative, positive. Okay. Okay. I'm going to skip problem 3. Now, problem 4. Yeah. I want to do this problem 4 because remember I told you about this one, integration by parts, right? Okay. So let's see how to do this. Okay. Because here in problem 4, you do not have a tabular integration, right? So we will use integration by parts. So let's take u equal to sine of 2x, and the du of this will be, let's see, I want to know what is the derivative of sine 2x. Okay, and we will take dv here, right? dv equal to e to the power of 3x dx, and tell me what is v. You get du when you find the derivative for sine of 2x. You get v when you integrate dv. Okay, that's for v. I got answer from Hannah Wink. Thank you. So when you integrate dv, you get 1 over 3 e to the power of 3x. Okay. What about this du? Yes, that's right, Joseph. So when you find the derivative of sine 2x, you get 2 cos of 2x. Do you guys want to know how I got 2 cos of 2x? No. You don't have to use substitution for this. Okay. This is like a chain rule. Okay. U equal to sine of 2x. We use substitution more often for integration. So whenever you are going to integrate a function, then we use substitution. We can also use substitution for differentiation as well. But most of the times we use for integrating the function. Okay. Okay. Let's see how to find u prime. So we have u equal to sine of 2x, right? So du with respect to dx. Now, whenever we have a function, inside function, right, we have 2x here. We do not have sine x. So remember, if you have u equal to sine of x, what will you do? You get du by dx as cos x, right? Cos of x. That's the formula. What if you have sine of 2x? Then we get the same thing, cos of x, but this time we have x as 2x here. And along with this, you have to apply differentiation for 2x as well. So 2x, derivative of 2x is 2, right? That's how you get du equal to 2 cos of 2x into dx. Okay. If you want to make a note of it, you can. I'm just going to erase this in a minute. Okay, now let's apply the formula here. So integration u into dv equal to uv minus integration of v into du. Okay, so integral, what is u? Sine of 2x, right? And what is dv? dv is e to the power of 3x dx equal to, what is u again? Just plug in whatever you have on the top. So v is 1 over 3 e to the power of 3x minus integral v is 1 over 3 e to the power of 3x du. du is 2 cos of 2x. Okay. Now I'm going to write that here. Just bring the constant to the front. E to the power of 3x sine of 2x minus, I'll just bring the constant outside because we have 2 here, 3 here. So that will be 2 by 3. Integral e to the power of 3x cos of 2x dx. Oops, I have to write dx here. Okay. Now we need to apply integration by parts here, right? Okay. I'll try to adjust here. So now remember we are integrating for this. We are going to apply integration by parts again for this type of problem. Now let's see what you get when you integrate e to the power of 3x cos of 2x into dx. Okay, so this time for this one, I'll just take it as u1 equal to cos of 2x, and du1 will be negative 2 sine of 2x because derivative of cos of x is negative sine. Okay, and we will take dv as e to the power of 3x into dx, and v as 1 over 3 e to the power of 3x. Okay, so apply this in the formula here, equal to u into v, u1 v1. So this is 1 here, this is 1 here. u1 v1, so I get e to the power of 3x cos of 2x divided by 3. u1 v1, okay, negative integral 1 over 3, which is e to the power of 3x, and du1. So I will write negative here, 2 sine of 2x into dx. Okay, and then simplification, e to the power of 3x cos of 2x divided by 3, positive because negative negative, so plus. I will take the constant outside, which becomes 2 over 3 e to the power of 3x sine of 2x into dx. Okay, now I will not integrate further, but let's see how to solve this, because if I keep on integrating, as I told you, if I again apply integration by parts to this integral, I will get same trigonometric functions. I have to keep doing it for infinity times because there is nowhere I can stop, right? What can we do here? Let me write the question again. The first question which we had was integration sine of 2x e to the power of 3x dx, right? Equal to 1 over 3 e to the power of 3x sine of 2x negative 2 by 3, and we had this integral, right? So I'm going to write that directly here. So that will give me 3x cos of 2x divided by 3 plus 2 by 3 integral e to the power of 3x sine of 2x into dx. Okay. Okay. Now observe very carefully here. Now this sine 2x 3x and this sine 2x 3x, right? Both are alike terms, both are same. So you can bring this one to the other side here, okay? And then we will subtract both of them and you will get a constant. You will get back the problem again. Let's see how to do that. Now, I am going to keep this here as it is, the question, e to the power of 3x dx. Now, this one, when I multiply 2 over 3, 2 by 3 inside this one, 2 is a 4, 3 is a 9. So you get 4 by 9, right? So I am going to bring the whole thing to the other side. Since this is negative, this also will be negative. When you bring to the other side, that will become positive. So 4 by 9 integral sine of 2x into e power 3x into dx equal to what? Equal to this term. Okay, sine of x by 3 negative 2 by 3 or 2 by 9 because 3, 3, 9 e to the power of 3x cos of 2x. I know it's a lot confusing, but you might have to try it again and again until you get that point. Okay, remember, you will be applying integration by parts twice. Now, if you keep on applying, it will go on and on. So what do? You search for the like terms here because the problem which is given is sine 2x e to the power of 3x. And I also have the same term on the other side. So why can't I just group the like terms to one side so that I will get back the question? Okay, you have to think like that. Okay, that's what I'm going to do here. Now, the last step, 1 plus 4 by 9. How did I get this? That's because I'm taking sine of 2x common, right? I'll take sine 2x e to the power of 3x to the one side. Yeah, and I will group the constants. That will be equal to e to the power of 3x sine 3x sine x by 3 minus 2 e to the power of 3x cos of 2x divided by 9. So it's 2x. 2x. It's a small typo. Okay. Now I'm going to keep the question on the other side. This is the question which was given, right? So 3x dx. So 1 plus 4 by 9. 13 by 9. Right? So 9. This is 13 by 9. So I'm going to bring that to the other side. Okay. So 9 by 13 because reciprocal of e to the power of 3x sine of 2x divided by 3 minus 2 e to the power of 3x cos of 2x divided by 9. This is your complete solution. Okay. I know it's way too long, right? Do you want me to explain this again? I mean, I guess you might be stuck at one point. So let me know which point you want me to explain. Or if you want me to explain it from the beginning, I can do that. Okay. I can repeat it from the start. You guys might be tired seeing at the solution. Yeah, I get it. Well, that's why we have a MATLAB. So you will see how a MATLAB will solve this problem in just 3 steps. Okay. Just let me know when you guys complete this writing so I can move with problem 6. Thank you. Okay. So when I was writing solutions, so every time before I start the lab, morning, I mean, I have your lab in the evening. So I also have one more lab in the afternoon. I had. So before that morning, I just sit and make solutions. I write each and every step so that if you get any questions, I can solve it very quickly. So I do that. I did that in the morning, and I saw when I solved this problem, it took me like one complete page. So then I thought, okay, I have to do this problem in the class, because when you do it, maybe the next day you might think, oh my God, this is too much. And yeah, because you have like terms here, right? So you might not observe it very quickly. So then you might apply integration by parts again and again, and you never stop. So I thought, okay, let me do this problem in the lab today. Okay, and we did this. So and also this is the only lengthy problem you have in this lab. So you don't have to worry too much about this. You can just write whatever I have written here, but before you write, just don't copy this. You have to understand and then write. Okay. Fine. So let us continue with problem 6. It is not too tough. This problem is not too tough. Um, I just want to do because we have a limits here. Now, particularly for this problem, you are going to apply integration by parts as well as the u substitution. Okay. So when you apply u substitution for the definite integral and you have limits, how will you convert those limits to the substitution whichever you have applied? Okay. For example, if you take u equal to 2x and then you find what is du by dx, right, which is 2, and then you find what is dx, that is du by 2, right? Now, if you have this type of problem, let's say you have 0 to 3, and you applied u substitution for this. This is just a random example. I know it's very simple, but let's say you have this type of problem and you have limits. Now, remember, you can't just plug in whatever you have here, and you just plug in the same limits. So whenever you are using u substitution, you have to change the limits as well. Okay, this is only for u substitution, not for integration by parts. Okay, this is only for u substitution. Okay. Okay. Okay, I'll just explain how you will be applying limits, okay? Because this is very simple. Now, when you have this type of problem, so what do? You will just put 0 to 3 and 2x you took it as u, dx was du by 2, right? So you will keep the constant outside, integration of u to the power of 1, so this will be u square by 2, right? Under the limits from what to what? Okay, you're not going to put 0 to 3 the same thing. No, you should not do that. When you use u substitution, the limits will change. So remember, you took u equal to 2x. Now you have limits for x, not for u, right? The limits which are given is for x, not for u, right? X equal to 0, x equal to 3. Okay, now u equal to 2x. When x equal to 0, u is 0. Okay, now here u equal to 2x. So when x equal to 3, u equal to 6. So the limits are 0 to 6. Okay, this is how you will be applying limits whenever you use the u substitution. Okay, I'll just erase this. This was just an example. We will see how to do this in the problem here. Okay, let's get started. Now we are going to apply integration by parts first and then use substitution. Okay. Okay, integration by parts, u equal to sine inverse of x. Now you might ask me, why did not I take u equal to 2x? You can, but I did like this because integration, for me, integration is it might take more steps when you compare it with the derivative. So I don't want to take complex functions under the integral. I want some easy functions and under the integral sign. So I'm just taking just because of that reason, just to make the calculations more easier. Okay. So I took u as sine inverse of x square. So derivative of this will be, I'll tell you that in a short. So dv will be equal to do x dx and v will be equal to x square, right? Integration of 2x is x square. Now, for u, the derivative of u, I'll just write it here, sine inverse of x square. Okay, remember in the d by dx of sine inverse of x, the standard formula is 1 divided by 1 minus x square. Okay, so we will apply the same formula here, 1 divided by square root of 1 minus x to the power of 4. Why 4? Because we have x here and you get x square, right? What if you have x square? Because this is x square. So this becomes x to the power of 4. Yes, there are 7 questions in this lab. Okay, and then when you have to derive this x square, that becomes 2x here. So I'm going to apply the same thing here. That's how you get 2x divided by square root of 1 minus x to the power of 4. Okay, I'll just erase this. Okay, now we will use the formula. I'll go to the formula directly. So it is u times v, so x square into sine inverse of x square minus integration of 2x cube, because we have x square here. When I multiply v into du, that becomes x cube, divided by square root of 1 minus x to the power of 4 dx. Oops, I always forget to put dx here. Okay, remember you have to use the limits. So for the first term, I will use 0 to 1 by square root of 2. And this is also 0 to 1 by square root of 2, right? We have everything in terms of x. So you're not going to change the limits. Now, how can I integrate this function? To do this, we use u substitution. Okay, this is where you use the u sub. Okay, so I will take u equal to 1 minus x to the power of 4. So du by dx will be minus 4x cubed dx, sorry, d. So dx will be equal to minus du by minus 4. Okay, so you are going to apply the same thing here. Now remember, the limits will change. So when u equal to 1 minus x to the power of 4, so x equal to 0, u is equal to 1. When x equal to 1 by square root of 2, that's the limit given in the problem, u will be equal to 3 by 4. Okay, this is a separate method. Okay, now that we know we have applied u substitution, let's see the final answer. So here, when you apply the limits, upper limit minus lower limit, let me write this as it is, and then we can apply the limits later on. So this is from 0 to 1 by square root of 2, negative integration. The limits will change. That is 1 to 3 by 4, half times dt by square root of t. Okay, I'll take this as t because we have already used, let's name it as t sub. Okay, dt t. So, okay, I will leave the rest of the calculations for you. Remember, the final answer you have to get has to be pi by 12 plus square root of 3 by 2 negative 1. Okay, all you have to do is apply the limits. Okay. Okay, so this will complete your lab 4. I'll give you some time to write, to take a note of this, and then we will see how to do this in the Matlab. Okay. Okay, let's go with Matlab. Okay, I'll just do a summary. Remember, for this lab, you're going to upload the Matlab code in a PDF format, and you are going to submit all the 7 problems with hand calculations. You can write in a sheet of paper, scan it, upload it as an image, or if you want, you can write in the same document, same lab document, upload it as a PDF. Okay. So first problem, you are going to apply the same formula, integration by parts. It is very simple. In problem 2, I have already done this. So you are going to use tabular integration and solve the integral. Okay. Now problem 3, you will take d as x cubed, I as cos of x. Find the derivative in the first column. In the second column, you're going to integrate the function. And you're going to stop until you reach the 0. Okay. And you will find the solution to this integral like we did in problem 2. So that will complete your problem 3. Now problem 4 was headache. It was too long. So we have also completed that. Only left out thing is you need to do this in your Matlab. It is just 3 lines of code. Okay, and problem 5, I just crashed it, but this is problem 5, secant cube of x. So this will also not take too much of time. Now, problem 6 was you had a definite integral, and we solved it using integration by parts. And also we had to use this USUB method to find this integral. So you learned how to do this as well. Now in question 7, the last problem, you have to fill this table. Okay. So whenever you write this in a sheet of paper, if you do not want to write on the document, if you want to just write it on a separate sheet, you have to include this table. This is very important. Okay. So for problem 7, you will take d as x square, I as sine of x, and then you keep on integrating and you will find the derivative. Okay. And then you will just add everything, cross multiply, and you will find the solution for this integral. So that will complete your lab 4. Okay. Now we will see how to do this in a Matlab. So you are going to, this is lab 4, integration by parts. Okay. You're going to put your name, your section number, date, and then switch back to code mode. So for problem 2, this is the same code like you did in the last lab. And then enter what is f. So problem 3, x cube, exponential 2x. Okay. And then we use int to find the integral of a function f with respect to x. Okay, very simple. Control enter. That's it. That will give you the solution. Remember, when we solved problem 2, I just kept it in a different form, right? This was not the simplified form, right? So Matlab will give you the solution in the most simplified form. Okay, both are correct. Section break and problem 3, problem 4. So again, since x, we use f equal to exp of 3 times x multiplied with sine of 2x. Then we use int with f with respect to x. Control enter. Okay, this was problem 4. Now, let me show you how to do this when you have a limits. So that was from problem 6. Remember, we took one complete page to solve problem 4. But in Matlab, we just did that in a 3-line, right? So next, we have problem 6. It is since x f equal to 2 times x times, okay, it is sine inverse. So sine inverse in Matlab is a sine, okay? We call sine inverse in a Matlab a sine of x square. And int function is f with respect to x, and then you give a lower bound. So lower bound is 0, comma upper bound, which is 1 divided by square root of 2. Okay, control enter. This is 0, I just gave it as 4. Okay, so this is how you have to do in the Matlab as well. So I just did it for 2, 4, 6, but I need all the complete all 7 problems, problem 1 to problem 7. Okay, do you have any questions till now?
Oh yeah, I have one question.
Yeah.
So you said that we don't have to have the answer in the complete simplified form, right? Like written out.
Come again?
Like whenever we have our final answer written out, it doesn't have to be in the simplest form, like in MATLAB.
Yeah, so you don't have to do that every time. So if you have in this form, that's fine. Okay, so all you have to do is just integrate. So if you have in this form, it's totally fine. Okay.
All right, thank you.
Any other questions? Okay, if not, we will meet in the next week. I hope your exam 1 goes well. All the best, everyone. Do well. Okay, so I will stop the recording here.